Okay, Bismillah Rahman Rahim. This is the binary tree or binary search tree basically. Um, if you're gonna represent that by the linker list, now we have done arrays and now the linker list. So we're gonna have three parts here. One is the data part, and one is a pointer to the left, and one is the pointer to the right. Okay, pointer to the left child, pointer to the right child. For example, this is my new left child, this is my new right child. So I'm gonna use the structure to have these three things. So I'm gonna have data here. That's happen to be long num, and of the same time, like structure record, we say here, and whatever it is, maybe you call it node. Better term will be to say node, and of this type, I'm gonna say left, and I'm gonna say right, and I type def to the tree tr. Then I'm gonna get declare the root, because we're gonna have some pointers. That's my root pointer, right? I'm gonna have root pointer, which always points to the previous one, right? Here we go. This is the first node, so we're gonna have the root definitely all the time. We're gonna have root here. This is the root pointer, which will point to this one. So if this address is 100, we're gonna have 100 here all the time, because we know it right from the single linker list we created. And if this has got an address of 200, here we're gonna have 200, and if you're gonna have here, say for example 300, we're gonna have here 300, and so on. So now we declare a structure, and I'm calling it as tr. We know it all. So I'm creating a root pointer, which initially holds the null, because initially we don't have anything. I'm going to have insert, that will return me the address, actually, which will return the root. But why we need it? Because we are doing the recursion, and we're gonna if you are here, for example, but if you create here, say hey, why will return root, but if you're here, we're gonna return this one, so that we understand that we are at here. And when we're here, we're gonna return this 3, this node. So therefore I'm creating recursively. I'm using the same function which creates this all, so I need this return type here, okay, which we'll understand shortly. Then we also pass the root, okay. If basically if you're talking, if you want to go here, we have to pass 0 to this function. If we want to go here, we have to pass 1 to this function. So similarly, and a digit which you want to put in, okay. So then we actually do 3 traversals: pre-order, in order, and post order. They are not returning anything, and we're gonna pass them the roots, because they're gonna have the root, and also recursively they will do this all. And count is simply 0. And in selection, to make my main function very simple, as a selection, not a big deal. What I do is I got a choice and got a digit, one in digit, and they say choice is equal select. What select does is basically it is having the selections, and I'm creating not to mess up with the main, so that I'm gonna select here. So this is in selection, I create selection, and I'm saying a lot of choices, as you can read. And when you got in the choice selection here, if the selection is less than 1, that means wrong choice, and selection greater than 5, that's again the wrong choice. I'm saying wrong choice, but I'm not going to leave you unless if it is less than 1 or choice selection is greater than 5. I'm not gonna leave you. I'm gonna ask you again, hey, come give me the right choice. When you're on the right choice, that means 1 to 5. You get anything right, 1 to 5, you will get rid of this while loop, basically do while loop, okay. Otherwise, if you do less than 1 and greater than 5, it will not leave you. This while will not leave you. It will take you back to the do and just ask you, hey man, give me this thing, okay. Maybe you put up the system CLS here, so that to clear the fuss, that you will do yourself. And then when you are done with the correct 1 to 5 choice, you return that selection, and that will land into the that selection will land into the choice here in the main, okay. So now I will switch choice, because if you said 1, that means you want to enter the integer. So we're asking, hey man, enter the integer. And to quite enter 0, maybe I put in the backslash n here, so that will be a new line, okay, nice and easy. And to quite enter 0, okay, maybe a little space there, and right now, and I put in into the digit, okay. I got a digit here, you put in the digit, okay. This is the first time you put in, but I'm gonna do this in the loop, because until you're not done, you say hey digit. When you press 0, so we say okay, you don't want to press more. So that's why I'm saying to quit enter 0. So while digit not equal 0, yeah, first time it's not equal 0, and you call the insert function and send it root and digit. So okay, but this time around the root is root, the first pointer, and but the next time around it will be a different thing. We have to go into the insert function to look into this recursion. Okay, it will. So what I'm saying, I'm calling the insert here first time. I call the insert and send it the root and then the digit. Okay, next time around I'm again asking for digit. If you have processed 0, for example, it will get out of it, that means you are done. If you're not, you're going to next number, you again call the insert and send this root there and digit there. Now I don't actually need this insert function to return me the root here, but I need it inside the insert function itself to return me the root, because this insert function is recursively. Otherwise I have no need here, right? So but I have to do it because I have to make this insert function which can return me the pointer of type structure, which happens to be here root. So I will catch it here also. So I have to make the proper syntax. Otherwise it's of no need, but it's necessary, because we understand necessary if you go into the insert function itself. So just go, let's move into the insert function. Here we go, insert function. That's what I'm saying. Hey man, insert function, you are returning the pointer. Okay, then we're sending it the root as we send it the first time. Just like you put in some value, say 10, that has gone to the digit, and you call the insert function, and we have sent the root also to it, which is catch it into the root itself. Okay, we could have kept the new name, but we kept the root here. Okay, and the digit has gone to the digit, and now they are all of type tr, because we're the second name for our structure. Now if I'm saying if root equals null, the first time around root is definitely equal to null, right? In the first time around root is definitely equal to null, because there's nothing in it, because this which I have made is not there, right? Let me make it a new copy of it, because this time around I got totally nothing in it, so root is null. Okay, here we go. Okay, come on, draw, give me the black pen. Okay, the first time around the root is nothing. Root has nothing in it, root has null in it. Definitely in the beginning root has null in it, so we are true here. So we're saying root is null. Okay, good. So what you say is I'm calling the malloc, we know it, we typecasting it, size of tr, and dropping into the root. So it's creating the node. So it's creating the node which has three things, and putting it here null, putting it here null, and the digit what you put in, say 10, that goes here. Okay, root arrow num is equal to digit. So root arrow num is this guy, root arrow left is this guy, root arrow right is this guy, and in both these guys we are putting the null here and count plus plus, and what it does is it will at the end return this root. I should put a slash here so that we understand this is not with this else. Basically it's out of this if else block. Okay, let me indent it properly. Okay, I guess I should take it a little back so that I understand this is returns root. Okay, it returns root this time around. It returns the root address. That is exactly okay. I'm putting up the new one. I should go here. So it's putting up the address of the root. Okay, it's putting root. That means this is 100. Say for example, we have in this now the 100, right? And it's turning this 100. Basically, it's turning the root. That means 100, and it goes back into this hut, wherein what we do is, we again, because that there in the loop will not leave us unless the digit is not equal to 0. So why is that? That is here. Okay, say for example we are not putting digit 0, we're putting say now the 5, and I'm calling the insert again, sending the root and the 5 in the digit, so it lands into the insert function again. Okay, it lands into the insert function, but this time around root is not equal to null. So yes, and root is root, the first one guy, the root is not equal to null definitely, so this will not run. But this is the only thing where I use the malloc and create the node. That means this has to run anyways. Why? Because if this will not run, it will go here. Else, if count this count is 1, is count %2 not equal to 0? That means it's odd. If it is odd, because we know if we come here, we know if this is the odd node, that's going to be left. Odd node left, even node right. Odd node is always left, and even node is right. Okay. So if we are at the odd node, that means we're going to go to the left. So what are we doing here? We say if count %2 not equal to 0, that means yeah, that's not equal to 0 because count is 1, and that means this is the remainder is not equal to 0, means this guy is the odd, so I should go to the left. So what I'm saying is root arrow left equals, what I'm doing, look what I'm doing, I'm saying insert, I'm calling the insert function and setting not the root, I'm setting root arrow left. This is the beauty of this program. It becomes so simple but little complex to understand. So I'm sending root arrow left to this function. Now it's calling the insert function itself. Insert function is here. It calls this function back. It's calling itself. That's the recursion. And root arrow left. It's sending root arrow left, which is copied into the root. Okay, that means if I go to my note, this guy, I am sending root arrow left. That means this pointer, basically this pointer which has null in it, and I'm setting this to this function. Now this root does not have is not this root. It's actually this guy. Okay, it's this pointer, this pointer one, right? So this pointer is copied here. So I said that's what TR root. I copied into the root, and now if root equals null, yeah, definitely it is null. So we are talking of this, not this, right? They're talking of this. Yeah, it is null. You create a node. Okay, you want to create a node, just create a node. Root is equal null, create a node. Okay, and how? Using the malloc, and drop the address in the root. When I say root here, it's actually we're talking of this pointer, right? So if this is address, say for example 200, this is gonna copy it here. 200 is copied here. That means this is linked to this. Okay, and drop the digit here. Say for example it was whatever it was. Drop it here. And drop null here, drop null here. Okay, you are done. And when you're done, you return the root. What you're basically returning? You are returning the what we are doing is here. This is temporary. This is actually the 200 is not copied here yet, because it's copied in the local variable of this insert function, that is this root, which happens to be a local variable. In this 200 is copied, and this root is basically returned. Now here, return root, it is returned, and where it will be catched, it will be catched here where the call was done by this. So root arrow left, and this root is actually this root, right? And root arrow left, that means this guy will return this root into this. Then now this 200 will be here. Getting me? Okay, now after that, when you've done it, it comes, because you got two turns now. If root, because firstly you have sent the root. Okay, now you said insert root arrow left. Okay, recursion. So you got two turns now. It gets after one turn, it goes back, it sends root arrow left. Okay, because when it calls the insert, it sends root arrow left to it. This means the second iteration of this insert will come up, and the root is copied, root arrow left is copied in this root, and it is doing this thing and returning the root. That's actually basically is returning this address 200. Now it goes like this, and it goes two turns, one turn and second turn. Here it returned the 200, right? Okay, goes back to the where it was called here, and copied that into root arrow left. This root this time means this root. Okay, root arrow left means this guy. Okay, put that 200 into here, and comes back and returns the root. Okay, it returns this root, which is copied again where the call was made. That was in the main when we did this. Again copied. Okay, now you're inserting again. Okay, you're inserting again. This is not the binary search tree. Basically this is the, sorry, as I told in the beginning, it's binary search tree. It's actually the binary tree, not search tree. So we are just creating left right left right left right, not the not on the basis of what, on the basis of data. So root is insert. I'm saying again you're putting a digit, say something else, say 25 now for example. Root is equal to insert and root comma digit. Okay, now I'm sending this time the root, again the root I'm sending, and I'm sending the digit 25, whatever it is, and insert is called. Now insert is called here. So we go to the insert function with the new digit, TR insert here. Okay, so that root is copied into this. This root is the top root. Okay, if root is null? No, it is not null. Else if count %2, because count is this time 2 %2 not equal 0, that's not true. So it will go for here, root arrow right. So in the root arrow right, that means let me give this guy root arrow right is equal to, so is equal to this one, insert, call the insert function and send it the root arrow right. You're sending this pointer, okay, and the digit itself. So if you're calling itself, now this time this pointer will be copied into this root. Okay, so this root is actually this one. So again this is null. Yeah, this is, if root is equal null, yep it is. Okay, what you're gonna do is you say root is equal to your asterisk malloc, create the new node here. Okay, and put in the null here on the both sides, and the data here, and count plus plus. Let's say we're gonna have 1 2 3 nodes. Now count is 3. Okay, and what you do is you return the because what happens is you call the insert function the root is not equal to null. It has gone here. Okay, so called itself from here, the call was made from here, right? It comes back to this. So and the root arrow right was copied into this, and this thing happened because at that time the root is actually root arrow left. That is null. Yes, that is. So do this and return the root. That's what is returning basically, is returning the new node. Okay, because you're putting in the root, you're putting in the something. That root is a temporary variable again of your that root is a temporary variable, this root. Okay, which this time has the address, say for example 300, new node's address, that is 300, and that's returned. Now this will return and this will be copied here when the call was made, root arrow right, that is this guy. This guy will copy it 300, so this is pointing to this. And after this you are done this, you go back one turn more, because here on now it has to go back to where it was. So it was here, root arrow right, and now after that this statement was left out, so return root, return this address back on. Now again you put up, say for example, another element. Okay, now this time around we got 3 nodes. Okay, and you call the insert function again and sending this root you're sending here, and the digit, some digit, say whatever it is. And I'm saying if root null, no, root is not null. Else if count %2 not equal to 0, yes, that's not equal to 0. So root arrow left is equal to insert root arrow left. So what happens, this little bit becomes more complex now. What happens, because I have to add it here now, I have to add here some element, okay, some node. Okay, it should go here. So what has happened, we are doing this thing, root arrow left. So I'm sending, because count %2, because 3 is not equal to 0, that means it's not. So I'm saying root arrow left is equal to insert. I'm calling the insert function and sending it root arrow left and digit. I'm sending root arrow left and digit. Now I'm sending root arrow left. Are you getting me? So see the diagrammatically, it's a little complex, but it's very simple. So you're sending root arrow left, that means you're sending this pointer, that means this time it has the 200, right? You're sending, it is inside is 200, right? You're sending this 200, this node, not node, sorry, this pointer you're sending to the insert itself. Now this pointer becomes the root. Is this null? No, this is not null. Okay, we're saying this is null. Now this is not null, this is 200, right? So again he will say if count %2, because count is 3, so 3% is not equal to 0. Yes, again root arrow left. Now you're sending root, this time is 200, this guy, 200 arrow left, that means this. Now you are sending this one. Okay, you are here, and what you do is now you say else, sorry, if you're saying root arrow left and calling the insert and sending this guy, and now that root arrow left, that means this guy, this pointer is copied in the root. Now is root null? Yes, this time it is null. Yep, it is null. So if it is null, what you're gonna do is you say root is equal to, you create the new node. Okay, drop the null here, drop the null here, drop the data here, and say count ++ to make count equal to 4, and get back, return the back. Then it has gone this thing, it returned back root. That time it returns this address 200 and returns into this. It will come back here where it's a call root arrow left, that means this one, because at that time root was this, and it goes back again to the root, which was the root itself, this one, because there were 3 turns, there are 3 calls of the function. One time it goes back here, second time it goes back here, third time it goes back here. Okay, similarly to do for all the things. Okay, it will go on turning, it will twist and untwist. So this is the power of recursion, becomes programming becomes so simple. Okay, so we are done with the digit while digit not equal to 0. So what happens is, until you are not putting a 0, but I'm putting up a 0 now, I'll say I'm finished. And here you say continue, because if you say break, it will do what? It will get out the loop. Okay, to get out this loop and try to see, because after that we have no statement. After that we have got no statement. Okay, it goes here, which is the outer loop, okay, like this. It is the outer do loop. Okay, 23. So what happens if you say break here in the while, in the case, switch case, you say break, it will go end of the loop, it will get you out of the switch case and get here, and then eventually get back the do. But if you say continue, it will not go back, it will go directly from here upwards. That's to make it a bit speedy. Okay. Okay, now you want to say pre-order, post in order, or post order. So you want to display something. So that's very simple now. Using the recursions, we can go for pre-order, and this does nothing but we're passing in the root. And I'm saying if root is not equal to null, if root is not equal to null, you print that root. Okay, you call yourself pre-order, you call yourself, and set it root arrow left, because root arrow left. Now root arrow left basically becomes the root, so it reads that. Okay, and wherein again it calls the pre-order root arrow left. Okay, because this will not happen, this will happen, and it calls it again, calls it until you don't have tr, unless you don't have any more nodes. Okay, because if root not equal to null, it gets back, but in the end the root becomes null. Okay, it comes into it untwists. When it untwists its last iteration, it has to read after that. That's pre-order root arrow right. Now it goes root arrow right. It starts reading the right of that, coming back, untwisting that. Now the pre-order root arrow right of that, and so on. You can work it on a copy because this becomes so complex if you don't understand on the copy. So similarly, we've got a in order. What it does first, root arrow left. Okay, we're gonna in order, we're gonna first left, then read the root, and then send the root arrow right to the in order. Okay, similarly post order, do root arrow left, then root arrow right, and then the root. Okay, work it on a copy, otherwise this is so complex if you don't understand. Okay, so with this we finished up our display, and this is the binary tree complete. That's all for this binary tree representation and linked list. Thanks for watching.